Hi, this is Aaron with iBoard Repair, and today I'll be recovering data from a Galaxy S22 Ultra. This phone has had ocean damage, so saltwater corrosion can be kind of difficult to deal with, and I've already taken the motherboard out of this housing, and I have it here under the scope, and I figured we'd start diagnosing it together, so let's take a look at it. So far I've done basically nothing to this board. I've just taken it out of the housing, and I've removed the camera here. And all four of these connectors are connected to the camera, the different cameras it has. And I do see a lot of corrosion around these connectors, but luckily I won't have to really make sure these ones are working. I just need to clear any shorts I might find because we don't need camera. This side will be a bit more important. And I have corrosion around a lot of my important FPCs here. Like this one will connect to the bottom board, and I can see I'm missing a full pin in here. And I might have some shorts as well. Um, Working with Galaxy water damage is a bit harder than iPhone, and that's because it's harder to work on the interposer on a Samsung. Uh, the solder is a lot higher melt temperature. It's basically the same as everything else on the board. Also, there's no jig that I can put this into. So with an iPhone board, I can take the data side of the board and use a donor bottom board that I know is good and put that in a jig. And a lot of the times that will help a lot of the problems that are on the board. But there is no jig for Samsung, so I have to make sure that my bottom board is also working in order to pull data from here. And I do have a donor board. I have a whole a whole donor I could transfer the CPU, the RAM, and the UFS memory chip to if I want to. But I have to decide if it's going to be easier to do that or if it's going to be easier to diagnose this board. And I'll also have to decide like if I need to harvest this connector from my donor board, if I want to do that, or if I want to just do the CPU swap. It will be kind of a shame to do that first and then realize I need to swap, then I have to swap that back. So I haven't done, like I said, anything to this board, but I think a good first step will be to check my main power rail, and ZXW does have a board view for this model, so let's pull that up and take a look at it. So here's my board view, and this would be like my main line, and probably the first line I should check to see if I have a short on. Looks like I have a few spots around here that I should be able to probe. So let's take a look at that, see if I have a short on this line or not. So if I measure this cap, this side is ground, and this side is giving me a fairly normal reading at 0.27. So that's a great sign. So this is where my battery will connect into, and it does seem to be partially short. And I'm going to go ahead and pull my donor motherboard and I'm going to compare readings because I'm not sure. I don't think that should be this low resistant, so I'll double check that. So I have my good donor board here. And if I take a diode mode measurement here, I'm getting 0.43. So that's definitely incorrect on my other board. So that's a partial short that I'll have to deal with. And normally when I have a partial short, it doesn't tend to be like a capacitor like this. It tends to be like a full chip. That's not always the case, but I've noticed that a lot of the time. So maybe if I'm lucky, I can just clear whatever this problem is. And then I can replace this connector. And maybe that's all it will need. I was prepared to do a full CPU swap on this video, but I'm thinking that's not going to be necessary anymore. So this is V battery, and this goes to the chips underneath this shield. So I'll pull this off and I'll take a look at these chips and see how they look. I do think there's going to be some corrosion down there. It is a bit difficult to get these shields off, but I'm going to try to just pull it off with some wire cutters and see how that goes. I will likely pull up some ground pads in the process, so you can expect that. That's not too much of a big deal. Not really sure the safest area to pull this at. There we go. And actually it looks quite clean under here, so that's a lot better than I expected. I thought I was going to see some corrosion around these chips, and that battery line goes under those. So I might be in the clear over here, and I might just go back to the other side and see if we can find a short over there. This line does go through the sandwich, and I'm hoping there's not corrosion on the sandwich pads itself. I will pull these first just to make sure. Maybe we'll get lucky and it's just one of these caps. Wasn't that one. It could also be either of these. It wasn't that one. And it wasn't that one. So if we look at the board view, we can see this is where I'm measuring short. That shouldn't be. I just removed these 3 capacitors. And this goes through the interposer, and into this chip over here. So it could be short right here, something like that, or partial short. This will almost surely have continuity across it as well. So it could be short from this side as well. And there's a lot more pads here that could possibly be short, or it could be short under either of these chips. However, I'm really thinking it's going to be corrosion in this general area inside the sandwich. I am also seeing the line goes over here. And this area was a bit corroded, so it's definitely worth taking a look at this area too. So that was right over here. You know, we might be lucky. It's very helpful that I have the donor here. So I can verify values. Well, that just fell right off. And the line is really only on these two pads, and then it will go through the resistors into other areas. But on this side, there's no short. This side is the line, that's still the 0.02. And then this side is 1.07, so this is not short. So we can just kind of disregard this area. It's not going to be our issue here. So it's looking more and more likely that it's going to be the interposer. And that's this area right over here. So I guess I'll try to use my thermal cam, and if I see heat in this area after injecting voltage, I'll most likely just have to do the full CPU swap onto the new board. So let's see what it looks like when I inject voltage here. So I do have quite a small amperage draw. In fact, it's like insanely small. I want to see if that just happened to have cleared the short by doing that. And it didn't, but it's not very big. 0.03 in diode mode when I should have 0.44, so quite a big difference. But it's drawing very little amperage. And maybe there's some shutoff feature on this Samsung, so it doesn't want to draw full amperage. See if I inject into the other side of this coil. Still about the same. Hard to say, hard to say. So I'm not sure what to make of that, because that amp draw is pretty minimal. It does appear that one of these is going to be the power button. And by shorting it to ground, I can prompt this to boot and see what it looks like. This one's ground, so it's one of these three is the power button. So I think that's what I'll do. I think I'll attach a wire to VPH power, and I'll prompt this to boot, and I'll see what the amperage draw looks like. Because it gives me such a small amperage draw when I touch power to VPH or to the battery line here, that it might just be possible for it to just power right through the short, and I might not actually even have to clear it. So I have a probe here with the wire attached. Looks like the wire broke a few times. Maybe I should put a new one on. Yeah, I think I'll need a longer wire. I'll attach a wire to here first. Now I'll attach this wire to the line. flip this over. I'll add a little bit of solder to this ground pin. And I'll attach this one to the ground. Like that. Now when I turn on my DC power supply, I'll have a small amperage draw. It's already gone back to normal. And it's probably this one that's my power, so I'm going to short these two lines. And that doesn't actually look like it's my power. Let's try a different one. That doesn't either. And that one is turning it on. So when I short these two lines, it's going to all the way up to 0.3 amperage draw. You know, it kind of looks like it's booting to me. It's hard to tell if it's fully booting, but it's not going back to 0. So I'm going to turn that off. And if I'm being honest, that looks kind of good enough to me. So what I'm going to do first is just put this into the good housing. And I want to see if it will just boot, see what will happen. I don't know exactly which pins are messed up here. But it does appear I only need one of them because these two are connected. So the fact that this one's missing might be okay. I will take a diode mode measurement on these capacitors to make sure they're not short. I'm not getting any readings, so let me check the donor board what that should be. Should be 0.2. Possible there's I just can't get a good reading on it, so I'm going to remove one of these capacitors and see if I can get a reading at that pad right there. Yeah, and it's 0.2, so it's not short at least, which is great. And I'll just clean this with some isopropyl. You know, and maybe this is just not as bad as it looks, and maybe it will just turn on. Maybe I'll get extremely lucky. Just throw this in a good housing, let's see what happens. Here's my good housing. And the screen's a little messed up on here, but it's good enough for me to pull data. And the connector that's really messed up is for my screen. So it's also possible I'll just feel this vibrate and not actually turn on. Let's prompt it to boot. Wow, it actually turned on. Can't actually see anything, so I don't know if it's going to be good enough. I had image for a little bit, but it seems to be gone now. So it doesn't appear that it's quite good enough. I'm going to test with my other motherboard to make sure the screen's still good. It is a very damaged screen. When I bought it, it wasn't supposed to be that damaged, but I did already test it and it looks good enough to turn on. But just to make sure, let's use this other motherboard, make sure it's turning on. So this is obviously a lot more clear. This is what I should be getting. As we can see, I have a very messed up screen, but it comes in and out and touch actually still works on it. Okay, so that's telling me either the connector is not good enough or the IC that controls image is damaged. But I'm really kind of just thinking it's going to be the connector. So what I'll do is I'll take diode mode measurements. I'll take diode mode measurements on each one of these pins and I'll compare them to the good one. And I'll see if there's any difference there. And if there's if I have like a short, that's the main thing I'll be looking for. Because that won't clear just by changing the connector. Well, it might, because there might be corrosion underneath it, but more likely I'll see like an open line, and if that's the case, I might just have to change the connector. And I am actually a little bit nervous about changing the connector on here because I don't want to damage the pads that are underneath here either. And I also do have to still consider that I don't have a normal diode motor reading on my connector here. In fact, this has gotten even worse. And that could also be a big contributing factor here. That makes me quite nervous at how bad this is. So right now that's giving me a 0.008 in diode mode, which shows that it's almost fully short. But when I inject voltage, it almost goes to normal. It does, so a normal, let's see what a normal amperage draw would look like. .02. Honestly, it's giving me just about a normal amperage draw. So again, I think it can power through that. It might just be some small corrosion bridges that's leaching the power, but it's not drawing too much. So yeah, I'll keep the same plan of action. I'm going to compare these diode mode measurements and see if I can get any differences here. So O, I'm going to say O when it's OL. O, 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 O. So I'll check that on the other one. O, 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 Oh, that's supposed to be 0.47. 0.47 here. 0.47. So already I have some missing lines. And I can already see that those pads down there are grayed out. So there's a good chance that it's just not making a good connection. No, I'm just going to check for shorts on any lines that doesn't look like it should be ground. So that one looks like it's ground. The pathway is opening up to ground. And then this opens up to ground as well. That looks like it should be ground. So I'm definitely missing some lines, but I don't have any shorts. So I'll go ahead and I'm gonna replace the connector. I think that might be good enough for me to pull data from this device. I don't usually flow low melt solder onto these pins when I do connector replacements, but in this case, because I'm going to be right above the sandwich and I don't want to mess it up, I think I'll go ahead and do that. So I'll apply some flux. And you know, I don't actually usually use my knife tip soldering tip, but I think in this case it will be the easiest way to apply solder here. And this is a lot of people's favorite tip, so I probably should use it a little bit more. Thing is, every tip has a right way to use it, and I don't really know the right way to use this tip because I don't use it very often. That actually looked like some solder went onto there at least. So it should be okay. This side has a little bit more room. Now, I'm not too worried about damaging this connector because this is just the one I'm taking off. But I can't really damage the donor board one very much. In fact, it doesn't actually look like the connector is getting damaged at all, which is nice to see. So hopefully that will allow me to remove this connector a little bit easier. I am also a little bit concerned because the V battery line goes right in this area, and by me applying heat to here, I might be flowing some of those, like I assume I have corrosion bridges to ground, I might be flowing some of those into more robust connections, and hopefully that doesn't happen. But for now, I'm just going to go ahead and remove this and see how it goes. I can definitely see the low melt melting already. So I'm glad to see that went on there pretty smoothly. Connector's not wanting to move though. I really hope I didn't mess up any sandwich pads. I pulled that off pretty rough because I really wanted it to come off. You know, I'm actually quite liking how that solder tip performed. Looks like it put down solder quite nicely on a lot of those pads. I'll obviously have to fix that resistor right there. Okay, okay, those pads look ready to accept a new FPC. So I'll go ahead and take it from this board. And you know, this is a perfectly good donor board now, except I'll be missing this FPC. So I want to try my best to also not damage this board, because I'm probably going to move this FPC back once I'm finished with the recovery. just in case I ever need this one for a CPU swap, because S22 Ultra motherboards are not cheap still. So I do have to be a lot more careful with this connector. And if I want to reuse this, I have to unbridge these pads. But I can't have this one fly away, and I can't have this one like snap when I pull it off. I have to pull it off a lot more carefully. So I also hope I don't mess up the sandwich on this board. But I'm less concerned on this one because, you know, this is not the data board. This is just a donor. You can always buy another donor. I just prefer not to if I don't have to. But I will have to be much more careful. I'm just going to be trying to slide it that way, by the way. Should be almost ready. And there we go. So that looks fine. I think I'll just go back and fix these really quick. There should already be a pretty good amount of low melt solder on here, so it shouldn't be too hard to attach. I do have a less than robust connection right here, but it does look like it's attached on the other one. I probably should have had the connection come this way more, the connector. But as long as I have a diode mode measurement here, then I should be fine. So I was missing values on these ones, and I have them now. I am missing it on that one, but it doesn't matter. These are all the same line. Oh wait, never mind. All three of these ones are good. And then I have the reading here, but I am missing it on this other pin. But that's okay. It only needs to be on one of them. I'm getting 26. I want to make sure that's the same right reading. Yeah, 26. So as you can see, these two are on the same line. So I really only need one connected. And it would have connected if I just pushed it more to that side, but a lot of that pad's missing, so that's the reason it didn't connect. So now I'm curious if my image will be working and if I can pull data from here. And I'm also curious to make sure that my amperage draw on the battery connector is still the same. I don't want that to have gotten worse. So diode mode measurement, still pretty bad, 0.007. I don't really even understand how it can be that bad and not give me a worse amperage draw, because the amperage draw still looks perfectly fine to me. Like there's no draw before prompt to boot. Looks better this time. Looks way better this time. I think we're probably going to be good to go. Let's see if I have the correct passcode, because that can be a problem. And if I do, I'll just be taking a smart switch backup and this will be complete. I still have to make sure that the touch function is working. And I'm in. Let's start this back up. So that really wasn't too bad. It just required a little bit of cleaning. I had to change that screen connector and clean up those pads and isopropyl all over the board and clean that up. It is strange that the battery FPC is giving me such a low diode mode reading, so that was 0.008. But my DC power supply wasn't giving me an amperage draw before prompt to boot, and when I did prompt to boot, it was giving me a normal enough amperage draw that it would turn on. The phone is just about done taking data from the computer right now, and yeah, that's that. So thanks for watching this. Thanks for stopping by. I hope you stop by again, and see you next time. Bye-bye.